All right, are we getting started then?
I think so, yeah. I think people just start trickling in soon.
Okay, and just to be sure, how much time do we have for this workshop?
I think this goes into 8:30
Okay,
or 8,
all right,
yeah, 8:30.
8:30, got it.
Yep.
All right, well, thank you all for joining this API 101 workshop today. My name is Claire Freilich, and I work at a company called Postman, which builds a tool for developers to work with something called APIs. I don't expect that you know anything about APIs, but I'm really glad you're here because APIs are something that will help you supercharge your development. So this is great. I know you have a hackathon coming up tomorrow that's only 24 hours long. So APIs can help be a shortcut to make your apps do really cool things in a short amount of time. We'll disclose what that mystery is in a little bit. But just before we go on, you can reach me at Claire Fro here on Twitter if you have any questions after the workshop, or you need help with APIs during the hackathon, and I'm happy to help you out. All right, so without further ado, let's dive into what we'll learn today. First, we'll cover what APIs are. I know maybe not all of you are familiar. To do that, we're going to learn a little bit about networks, so understanding what servers are, what clients are. We'll practice making some HTTP requests to an API, a real-world API, and of course, understand what comes back. Finally, I want to equip you with the ability to use APIs in your projects so that if you would like, tomorrow, you can incorporate them into your projects. All right, so we keep saying API, API. What does this stand for? API stands for Application Programming Interface. And the I in this acronym is very important, interface. Basically, an API is a simplified interface for allowing code to talk to code. It's how you can integrate different services to talk to each other. So APIs help you as a developer add exciting new features to your applications, or build complicated automations that have just the computer talking to other code in the background. Also, if you can make an API a product. So some companies out there, their entire product is an API. For example, Stripe is an API product that allows developers to incorporate payments into their apps. So this whole, interface that simplifies making payments in your apps has become a business. And opening up your product like that allows for even more innovation on your product. An example of that would be Twitter and Facebook. Both of these products have APIs that allow developers to connect to Twitter and Facebook programmatically. So you don't have to go clicking around the website to get user data. You can make programmatic API calls in order to get user data. So all of that allows for a product to evolve very quickly. All right, so let's think of this as an analogy, and maybe it will make more sense. You can think of an API like a waiter at a digital restaurant. When you go to a restaurant, maybe you want some soup. You don't have to know how to make soup, but you have to know how to ask for soup. So you don't go walk into the restaurant, head to the back kitchen, and start cooking yourself. Instead, you talk to a waiter and say, yes, I would like the beef stew, please. And this waiter acts as the go-between between the front end, the lobby of the restaurant, and the back end, which is the kitchen. So the waiter will tell the chef, yeah, we had an order for soup. The chef will process your order, get all the ingredients, make your soup, and give it back to the waiter to give to you. So again, you didn't have to know how to make soup. You just have to know how to ask for it. The same thing with an API. The client could be an application or a web browser, can ask for data or services through an API. And so this API will be the go-between between the client and the backend server to fetch user data from Twitter, for example, or to send an email. So again, this API is that simplified interface. You as a developer don't have to know how to, query Twitter's database or anything, and you probably shouldn't know, that's a secure thing, but you know how to ask Twitter's API how to do that, and Twitter can go and grab user data and bring it back to you. And in case you're wondering, there's an API for almost anything out there. For sure, all of your favorite products like, Twitter and Facebook and Spotify, they have APIs that allow you to interact with their data programmatically. But maybe some more that you rely on but don't know you're using, such as Twilio. This is a very popular API for developers to send text messages to your phone. Twilio also has an API called SendGrid that will allow you to send transactional emails. Let's say like you have a user sign up or they need to reset their password on your platform. You can use the SendGrid API to send an email to them to reset their password. We mentioned Stripe earlier. This is an API that will allow you to incorporate credit card payments into your app. So let's say you want users to subscribe for some service in your application or to donate money through your website. You can use Stripe's API for that. And you can get the current weather through the API, tons of things. Essentially in Google, if you type anything API, you're probably going to find something come up. There's even an API that will give you random Kanye West quotes. So again, all of these little different APIs you can piece together like Lego bricks to build really complex and useful applications. Before we actually play around with an API, I just want to give you a little history about the then and now of developing with APIs. Of course, in the past, you could type this curl command into your terminal to hit an API endpoint and see what comes back from the API. This works great. You can still do this. The only disadvantage is, when you're working in the terminal, nothing is always really clearly formatted. As you work more and more, it's going to disappear in the river of the terminal, whatever you get back. It's kind of tedious to do this as a developer. That's where Postman comes in. Postman is an application that will make working with APIs much more visual for you. So it will show you how you can make a request to an API. It will show you exactly what the response looks like that came back with nice colored indentation. You can save the responses, you can save your requests and share them with your team. This is great in the hackathon setting, for example, if you have a team of a couple people and you want to both work on using an API. Postman is the perfect collaborative tool for doing that. Postman does a lot more than just make API calls. It even lets you build APIs and helps you monitor APIs, build fake servers to test out your APIs, tons and tons of stuff. But we're going to focus on the API client side of Postman today. And just a little background about Postman. Again, Postman is an API platform. It's going to make working with APIs much easier for you by making it visual. And that's why we're trusted by over 98% of Fortune 500 companies and 65% of the Global 2000. This number has gone up since this slide has been made, but we're obviously trusted by a lot of big names. And if you start using Postman now, you're going to be ahead of the game if you're looking for jobs in the future, because a lot of these companies are already familiar with Postman and using it internally in their teams. So it's never too early to get familiar. At the end of the slideshow today, I'll show you a link where you can learn, get Postman certified for free if you're interested. We just crossed the 20 million developer mark, by the way. We're really excited. All right, so we've been talking a lot of theory. I think it's going to help if we actually learn a little bit about what requests and responses look like. And we'll do a little bit of talking about networking in computer science here. So APIs work with the request response pattern, where you have a client that just makes a request over some network to a server. The server will then interpret the request and send back a response. And that's as complicated as it is. It's just a call and response. But it's important to know the names of the players here. The client is the entity making the request, and the server is the entity processing the request. So you actually do this without knowing it every day. So how do you make a request to a server? There's a couple of ingredients. The bare minimum you need to make a request is an HTTP method and an endpoint. So that's kind of like the how and the where. Then there's extra things we can add to our request, like parameters, headers, and a request body. Well, we'll get into those in a bit. So again, those first two ingredients, a method and an endpoint. Here we see an example of a method called get. With HTTP requests, there's 5 really common methods, one called get, post, put, patch, and delete. And these all represent different actions you can perform on a database, basically. Get, you can use to retrieve information. Post is used for sending information. Put and patch are used to update information that already exists. And then delete is what it sounds like, to delete. These are not the only methods in HTTP, but these are some common convention ones that you'll definitely run across. So that's the method side. And then we need to know where we're making the request. And that's what the endpoint is. So for example, here we have google.com/search. This is a URL, maybe you've been here before, but let's break it down a little bit. This request is composed of a couple of parts. The first part is the protocol. Here we have HTTPS, which means it's an encrypted HTTP request that's more secure. We have the host, google.com. This is where the server lives. And on the host, whatever comes after the slash is going to be your path. This is kind of like the local street address on the city, essentially, that would be the host, right? So on the Google server, there's a /search path that's going to handle any search requests. And let's just take a look at this and see what's happening when we go visit Google in the browser. So I'm going to open a new tab here. And oops, I'll get rid of my bookmarks. All right, so we can go to google.com. Probably been here before. I'll make it a bit bigger. Now, you may or may not be familiar that within web browsers, you can right click on the page and say inspect to see what's going on behind the scenes in this browser page. This will open up a developer tools pane that tells you all of the HTML that you're seeing here. You can see any logs in the console here. We're going to look at the network tab to see what's happening when we hit google.com. So right now you see there's nothing in here. If I refresh the page, you can see what's happening when we hit google.com. It triggers a bunch of requests over the network. We're going to be interested in one request in particular, which is from the google.com server. I'm not seeing it here. Let's go to the all tab. All right. Yeah. So these are all of these network requests were made when we hit google.com. And that's because Google has a bunch of fancy tracking stuff going on. You can dive in here and see what exactly is happening. We just want to see what happens when we hit google.com server here. So I'll click on google.com and you can see the response we got back from the server is this. This is an HTML document. You can tell from this tag right here. And this is actually the web page that's being loaded here. So what's happening when you enter requests into a web browser is you're actually making a GET request. Web browsers are really good at making GET requests to this address. And so that's sending our request over the server or over the network. And Google's server is sending us back a response with the HTML that's getting rendered here. So this is an example of the call and response cycle. I want to show you, now that we've looked at this in the Chrome web tools here, we can do the same thing in Postman. So first I'm going to copy the google.com URL. And I'm going to head over to Postman. Now, the cool thing about Postman is A, it's free. B, you don't have to download anything. You can actually use this tool right in your browser. So when I go to postman.com, now it takes me right into the tool because I'm already signed in. And you can sign up for free. If you go to postman.com, in the upper right, there'll be like a create account button. It takes a couple of seconds and you'll have an account. And then you're good to go. And you'll see a page like I have here. So the first thing you have to know about Postman is any work you do is done inside of a workspace. I'm going to go ahead and open the workspace drop down here and create a new workspace so we can, play around today. It's going to give me a form to name our workspace. I'll call it TOHacks 22. Then it gives me the option what kind of visibility I want. For example, if you're doing work with a team, maybe you want to share your workspace with your teammates, or maybe you want to share your workspace publicly with the whole World Wide Web. In my case, I'm just going to make a personal workspace today, so my team doesn't have to see it, but you're welcome to use any visibility you like. All right, so I click Create Workspace, and Postman has built me a new workspace to start building requests. What you want to do is head to the Collections tab. A collection is a fancy name for a folder that's going to hold your requests. And right now we have no collections, so I'll create a new collection to play around with the Google requests we're going to make. I can name it, we'll call it Google. And you can see our collections over here in the navigation for collections. So now that we have a collection folder, we can start adding requests. I'm going to add a new request by clicking Add a Request. And here, we'll just call this request Google Homepage. And you can see by default, Postman has us set to a GET request. Here's a list of all the other types of requests you can make. Notice you'll see post, put, patch, delete. Those are familiar to us. We also have these other ones that are a little less common, but definitely valuable to know about. But we're going to make a GET request, which is what we're doing in the browser. Oops. And I'm going to paste Google's URL in here, hit save. And to make our request, we just hit the blue send button. So this is going to send a GET request to www.google.com. And down in the bottom half of Postman is where you'll see the response data. So remember, we just did this in the web browser and used the network tab of the DevTools to see the HTML that came back. But it's not indented. It's like crazy long and kind of hard to read. Nice thing about Postman is it's all nicely indented. You can read it very easily. There's color coding. It's very easy to read. A cool thing here in Postman too is when you get an HTML response like this, you can click preview and it's going to render that HTML response right here. You'll notice it looks a little funky, and that's because when you hit the Google website, you're making multiple requests, as you saw over here, right? We're not just hitting google.com, we're going out and fetching like CSS assets, we're fetching images. That's why you don't see the Google logo here, because that's a separate request to get the logo. And the styling looks a little funny because it's a separate request to get the CSS. But this is like the bare bones document that comes back from Google. All right, so this is all to show what requests and response looks like, where that happens in Postman. Of course, google.com is a website. It's not necessarily an API. An API, remember, is where you're doing everything programmatically. Sometimes you'll get HTML back, but we want to get some other data types, which we'll play with in a second. All right, so again, well, let's actually play with the path thing for a second. Let's make a second request called Google Search. I'm going to duplicate our current request because it's pretty much the same URL, except I'll rename it to Google Search. Oops, over here. Google Search. It's still a GET request, but just to illustrate what happens when we type something in here, if I say TOHacks in the search bar in Google, you'll see we hit the google.com server, and it's sent back because we had some data in the search bar. It redirected us to a path on the server called /search. Remember, we saw that earlier. So this is where the search functionality in Google is handled on their server. And you can see there's a couple of things added to the end. Look at all this. This is going to be very small on your screen, maybe, but we'll break this down in a second. All of this stuff after search, you see there's a small question mark. Everything after this question mark is something called a query parameter. Let's take a look at what those are. They allow us to add a little extra specificity to any path. So we know we're at /search, but we also have some extra information. For example, query parameters always start with a question mark and come at the end of your path. Anything after that is going to be a bunch of key value pairs that they're just strings that describe extra information. So for example, this is true with the Google search path. If you have a question mark and then a Q, this stands for query, equals is what separates the key and the value. And we have a value of cat. So this is if you're making a search query to Google of cat. You can have multiple query parameters and they're separated by an ampersand. So the ampersand is kind of like a comma of your key value pairs. And we can see this in action in the URL that we have up here. We see Q equals TOHacks. That's what we searched in the search bar. And there's an ampersand for the next query parameter. And we see source equals HP. This is some code on Google's side that's probably talking about where we did our search from. And a whole bunch of other similar stuff. It's really hard to read in this bar up here. So I'm going to copy it, all of it verbatim, and head into Postman. And in our Google search, I'm just going to paste that GET request right here. You see it's very long. But when I click away, you can see Postman here in the request params tab has pulled out all of those query parameters. So you can see, yes, Q equals TOHacks is here with Q, TOHacks, the key and the value. We can see there's one called source, HP, EI, this crazy long string. I'm sure all of these down here have something to do with tracking us, because this is Google. But Postman obviously makes this a much easier interface to work around with. And you'll notice you can change stuff up here and it will automatically sync up in the URL up top. Another cool thing in Postman is you can toggle these query parameters on and off in real time. So let's say I don't want all of these crazy tracking things. You can uncheck, 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 and you can see as we're doing that in real time, the URL up here is updating. So we could change this search right here to Postman. And you see it's updated. Now we have Q equals Postman as our query parameter on the search path. So if I hit send this time, we're going to get back some HTML. But if we preview and see what this HTML renders to, you can see Postman is pre-populated right here in the search bar. And that's all thanks to the query parameter that we're sending to Google server. So again, we still haven't quite gotten to APIs, but it's really important to understand what a query parameter is, what a path is, and how to incorporate that into your APIs calls. We've talked about query parameters. There's one other type of parameter you might see in an API, and that is a path parameter. It looks kind of similar, so it's easy to get confused in the beginning, but the difference is a path parameter is like a dynamic chunk of your path. So it's not something that comes after the question mark. It's any part of your path that changes. So a good example of this would be if you're on twitter.com, you go to / somebody's username. It's always twitter.com/something, but that something is something that changes. So because it's dynamic and it comes directly after the /, that is an example of a path parameter. Oftentimes path parameters are used to hold ID values, but that's not a hard set rule. Again, APIs are coded by humans, so the developer can decide how they want to architecture. It's always important to read the documentation of an API to understand how to use it. Just be familiar with path parameters. In Postman, of course, Postman's here to help you make your API requests. We've just dealt with, in the params tab, this is query params here. But if you had any path parameter, I could start typing up here /search/ and if I say : my path variable, as I was typing that, Postman added a path variables table down here that has the name of our path variable that we nicknamed right here, and we can give it some value like foo. Of course, Google's not expecting this, but this is how you can inject a path variable into your request URL using Postman. So let's get rid of this because we don't need it, and just save what we have. All right, so again, this is really cool. Like if I was working on a team, I could share this collection with my team. They can see what these endpoints are. We could even save the response we get back as an example. And you can see Postman will save the response underneath. So anybody coming can see an example of what comes back from this request, which is awesome for collaboration. All right, so we're at the half-hour mark. Let's see, we've got a couple more things to talk about. There's other things we can have in our request, such as headers. This is what the metadata, so something that isn't necessarily our request payload itself, but information about our request, we can add in the headers. Headers are used for things like authorization. You don't want every API to be open to the worldwide anybody can use it. I can't just go posting on your Twitter without your permission. So I need to be authorized to do that. That information might appear in the headers. You don't have to memorize any of these. The cool thing about Postman is just like the params tab, there's a headers tab. Oops, let's go to the actual request. The headers tab here. Here's some headers that Postman automatically adds to your request. You don't have to know what these are. The cool thing about Postman is you can hover on the little tooltip and it's going to say why Postman recommends using this header, what it is, and allows you to add extra headers if you need to. In addition to headers, you can add a body to your request. So for example, if you need to send data to an API, you're going to add a payload in the body. Let's say you're signing up for a new account somewhere. You might send the username and password and all that form data as a body of your request. And there's many different types of data you can send in your body. You can send form data like we just mentioned. You can send JSON or JavaScript object notation data, which looks a little something like this. It opens and closes with curly braces. This is how you identify an object in JavaScript. And then it's a bunch of key value pairs where the key is a string and the value is a string or a number, a Boolean, another object or an array. It's pretty intuitive to read JSON. And the cool thing is, yes, it's called JavaScript object notation, but it's language agnostic. You can use this data type to talk to any API. It doesn't matter if it's coded in JavaScript or not. You can send text, you can send HTML or XML, you can send files to an API. You can send what's called a GraphQL query and much, much more. Postman is going to help you out here in the body tab right here. So you can see all those data types we just talked about. If you had to send form data, for example, you could do that here. If you're going to send JSON data, you can click this raw button, and instead of text, you can say JSON and put some JSON object in here, like, you know, my variable and so. And this is going to be attached to your request when you send it. Of course, we're making a GET request here. There's nothing we're really usually use a body with like a post or a patch request to show updated data. So we won't use that example here. All right, and before we do like the final cool calling a real API thing, I just want to talk a little bit about the response. The response, you can have a lot of the same things that you put in the request. The server might send back some headers. For example, the headers might describe when you last made your request. It might describe how many requests this IP address is allowed to continue making. You can also send back a body. We saw that, sorry, here in our Google search. If I hit send, and we see the response down here. What we're seeing here is the body tab. Our body, in this case, it's an HTML document that got sent back, but maybe you get JSON data back. But what else is unique about the response is you get a status code from the server. And this is not an exhaustive list of status codes and certainly not something you have to memorize. If you take anything away from this slide, I just want you to know that each status code starts with a number, and that number indicates some, response status type. For example, any response code that starts with a 2 indicates success. Your response came back okay. Any response code that starts with a 3 means redirection. So you hit some path on the server that maybe moved somewhere else, you get redirected. That would be a 301 moved. 400, any 400 level response code means the client did something wrong in making the request. It means a client error. Common examples of this is like a bad request. Your API was expecting a string data type in your JSON, but you sent a number, for example. You might get a 400 error there. Probably many of you have seen the 404 error when you're cruising the web and you hit a web page that doesn't exist. Same thing with an API. If you try to access a resource that doesn't exist, you might get a 404 error. Lastly, there's 500 level errors. These ones you can't do anything about because it's a server problem. The server might be on fire. Maybe there's too many people trying to access the server at once and it's just taking too long to make responses. You might get a gateway timeout, for example. So again, you don't have to memorize these. And what's really cool about Postman is you can see right here, the status code, comes back with the response, you can hover on the status code and Postman will explain what that response code means. So this is a great way to learn the response codes, I find. For example, we got a 200, which is an okay, thumbs up. Remember, anything that starts with a 2 is good. If we went to some random path on Google's server that doesn't exist, like that, and hit send, you can see now we're getting back a 404 not found status. Okay, so Postman's going to explain what that means. Other things Postman shows you is how long it took for the response to come back. It tells you the size of the response. There's all sorts of cool stuff you can see. You can see what cookies came back. These are what Google's using to track us. We can see what headers came back from the servers here in the response. So again, everything, the request and the response is all visualized here. It's very useful when you're starting to learn how to talk to APIs. All right, we have about 12 minutes left. We've been talking about network requests and Postman so far. Finally, let's learn how to call a real world API and see what that looks like. I'm going to be using the GitHub API today to demonstrate this. For those of you that are not familiar with GitHub, it is a repository hub where you can store documents and retrieve documents with their version history. And this is very popular with coders, obviously, to use versioning when they're coding out their applications. You can upload your code to GitHub and it will be visible to the whole world or to a private team. Many of you may have been to GitHub on their website before. We can take a quick look at what that looks like. If I go to github.com. So I have a GitHub account. So this is what it looks like when you get inside. If you go to your profile, this is my profile, and you can see I have a bunch of repositories up here. And this is just, projects that I've built. If I click on any of these projects, like, I don't know, To-Do API, you can see the code is all here. And its version history is all, stored here as well. This is great. I can click around here and look at stuff. But what if I am building an application and I want to get information about this user or this repository programmatically so that you don't have to click around, and I want to use that in my app? That's where APIs come into play. So instead of the GitHub website, we can use GitHub's API. So I'm just going to type GitHub API into the Google search, and what comes up right away is the documentation. I mentioned this earlier, you'll never know how to use an API unless you read the documentation. APIs have conventions, of course, and you'll get familiar with those as you use them, but every API is coded differently. So the only way you'll know how to use it is by reading documentation. You can see this is the documentation for the GitHub API. On the overview or the quick start here, we can click. You can see how you contact or call this API. They give you a quick hello world example. You'll see that they're using curl here. That's that command line way of calling an API. We can do the same thing in Postman. I'll just copy this example endpoint. You can see this endpoint has the protocol HTTPS. It's api.github.com is the host. So not github.com, but api.github.com. And then the path here is Zen. And I guess this gives you quotes, I believe, random quotes from GitHub. So I'm going to copy this endpoint, head into Postman. So far, we were playing around in Google. I'll just leave that in the Google collection. We're shifting gears into GitHub now. So I'm going to make a new collection with the plus sign. I'll name it GitHub. And inside, I can add a request. By the way, when you see a request that has no method, the default method is get. So we're going to do that. Make another get request here, paste in the endpoint /zen. I saved it and I'll hit send. So what's happened here is we've made a request to the api.github.com server and it sent back a response. The response is right here. Practicality beats purity. It just sends back a text quote. So we have officially fetched our first data from a real world API. Congratulations. But this is not super useful for any application that we would build unless you have a quotes of the day app. That's cool too. But we want to actually get real world data. So let's say that, well, we'll call this the Zen request. Let's say we want to get user information from GitHub. I'm going to click the ... on our collection and add a new request. We'll call this get user info. Oops. And I'm guessing it's going to be a get request. We'll have to check the documentation. We'll also need the endpoint. So let's head to the documentation. We know that the base URL for this API is api.github.com. So I'll head over here and paste that right in. We need to know the path for getting a user. So to do that, we can see this is the API reference. These are all the things you can do with the GitHub API. You can, interact with commits. You can interact with GitHub issues, with different metrics, different GitHub pages, projects, repositories, and users down here. So if I click on the users resource, this is all the stuff we can do. We can get the authenticated user. That means whichever user is currently logged in. That would be using some headers. But we just want to do a public request to list all the users on GitHub. That'd be kind of crazy. Here, we can get a user. Here we can see the path. It says that the method is get and the path is /user/username. And this is going to be an example of a path variable that we talked about earlier, some dynamic part of the path that can change. I'm going to copy this path and head over to Postman. I'll paste our path onto our base URL there. And I'm going to make a quick change. In Postman, there's a special syntax for path variables. Again, you can put a colon, those 2 dots, right before your path variable name. And that's going to add a path variables table down here. Now we have this place we can actually type in a username. For example, mine is Clarefro. And this is the exact same thing as directly, calling /user/Clarefro up here. It's just like doing, without the colon, like that. And I'll send this to show you what comes back. And here we're getting data back from GitHub's API. You can see my login name, my GitHub ID. There's a link to my avatar URL. I can click on this and send it, and Postman make a separate request to show my avatar. But I'll discard this one. We can see all these important links to different areas of my account. You can see what company I work for if it was there. You can see where I'm located, which is out of date. You can see how many repos I have, how many followers I have, how many following I have, and even when I created my account. So you can imagine the types of things you can do with this data. You know that you're always going to get data in this shape. That's what an API does. It promises to give you back data that the documentation says will give you back. We'll always get the avatar, we'll always get the location, etc. So if you're making an application that needs users, build a user profile, you can always get their name, you can get their location and map that into your application. Because what we're getting back here is just a JSON object in our response. So you can manipulate that in any programming language to do with it what you will. We just made that request with hard coding the username into the path. Again, we can give that path variable a nickname like username, and Postman gives us the path variable down here. I can type Clarefro and hit send, and we're making the exact same request and getting the same data back. I can do this for another user. Anybody want to throw into the Zoom chat their GitHub username if they have one, and we can look at your data in real time? Only do this if you're okay with, sharing. We don't get to see anything too private in here, but, All right, so Addy added Addy Rao projects. I'm going to now just paste that right here into the path variable value. And now if I hit send, oh, maybe I misspelled. Oh, I see you've changed it here. Without the dot, it's a dash. You see we got a 404 error. That's a good example of find a resource that's not found in the API. All right, so I'm going to send. We get another 404. I didn't change it. Needs to be a dash. All right, send. Finally, we get a 200 OK, means things went well. And we can actually see some data about this account. We can see the name. We can see even the Twitter username in here. You've had an account since March of 2020. and you don't have any, oh, you have 6 public repos right now. So this is all cool. This is data that you can map into your application. We've got another one here from Varun. I'm going to paste that. You can see every time we're doing this, we're getting the exact same shape of the data back. And that is the contract that is an API, right? So yeah, we can see public repos 3, name here. There's a link to the blog. That's awesome. You can get all this types of data from the API. Why is this cool again? Now you can automate stuff. You can map it into your applications. Unlike the GitHub website, which you could scrape, you know, to get the username from like the github.com website. But if the GitHub developers ever change the website, your whole application would break, right? Your application wouldn't know where to find the name. The API promises to always send back data in this shape, so you always have it. And the one last thing I'll show you, how are you going to integrate this into your projects? The cool thing about Postman is there's a little tab on every request called code in the far right. If you open that up, it's going to open a snippets menu. And here's a bunch of coding languages of how to make this HTTP request you just built in Postman in various languages. For example, with PHP, it might look like this. To make this request, you can see the URL is right here. What about JavaScript fetch? It might look like this. There's a couple of extra information that maybe we don't need, like cookies and stuff. Postman gives you everything that you've built here. You can see curl, for example. I can just copy this and paste this into my terminal. Open a terminal window here, make it a bit bigger. Just paste what we took from Postman. You can see it's making a curl request to get blah, 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 github.com/users/Varun's username. And if I press enter, it's actually going to print all the data here right into our terminal. So this is an example of how Postman snippets can help you hit the ground running. If you're building like a JavaScript application, you can just copy this, put it into your code, and this is how you can get this data there. And of course, you can edit this and to your heart's content, however you'd like to use it in your application. All right, so that's just barely touching the iceberg of the stuff you can do. We've only made a GET request example, but if you poke around the GitHub API a bit more, you'll see there's documentation on how to make other types of requests. For example, if we look at the repos, there's a GET request here. Here's a POST request. If you want to create an org repo, you can actually like create repositories from an API. You can edit them, you can delete them. Of course, these require what's called authorization. I can't just go in and delete or create repos on Varun's behalf without being Varun. And you have to use something called auth to do that. This documentation will teach you how to add auth to your requests, and Postman also makes adding auth very easy. As you can see in the request tab, there's an auth option. I'll close this for a little more space. And every API is different. Postman has a ton of different ways to accommodate auth for various APIs. GitHub's API uses either OAuth or basic auth. You can read the documentation if you're curious about doing more advanced stuff with the API. All right, so I've been talking a lot. I want to leave a little room for questions, but before I do, I've created a repository that you can play around with in Postman that covers all of the stuff that we did today. B, if you're interested in APIs and Postman and want to learn more, we have a free certification called Postman Student Expert that anybody can start immediately and learn all the basics of APIs, do some things a little bit more advanced than we did today, like variables and like using scripts to automate parts of your request. You can find this training just by, I don't know if I can share a link. I can share the link to these slides actually in the Zoom chat. The link will be in here right on the next slide. How to become a student expert. You can also just Google search Postman Student Expert and you'll find the application form to get started. Another thing to know about is we have a Postman student community Discord. So if you're working with APIs, maybe during the hackathon, Feel free to join our Discord on this link, and you can ask questions and get answers in real time. There's thousands of people in there talking about the APIs and their projects. We do hackathons, we do swag events, and lots of fun stuff happening in there. Feel free to join and get support. And lastly, if you think Postman might be interesting for your educator or for your peers in your classroom, we also provide API teaching materials for teachers and free Postman licenses for educators too, to use like advanced Postman features. So you can point your educator to the Postman classroom program if that sounds interesting to you. All right, last thing. I promise I'll leave a little time for questions. Obviously, you all are entering your hackathon period tomorrow. That's really exciting. I mentioned APIs are great because you can add really advanced features to your projects easily using them. And I wanted to leave you with a resource where you can find some APIs. So there's a link here. I've compiled a list of free APIs out there that are easy to use. You can get like COVID data, for example, from this API. There's environmental data like air pollution, electric car charging station locations, astronomy. There's the Twitter API here. That one's a bit more complicated because you have to authorize to use it, but there's instructions on how to do that. Maybe you want to make like a finance app. There's currency exchange APIs, cryptocurrency APIs, and some news APIs to get the news. All of this is pretty accessible. This is a short list, but you can find an even longer list here at public APIs. There's a GitHub repo that has a ton of APIs by category. You scroll down here and see there's like pretty much an API for anything you can think of. All right, so that is the intro to APIs and Postman. We have about 5 minutes left. If anybody has any questions about APIs, about Postman, or if they want to share what they're thinking of building tomorrow, we can talk about APIs for it if you like. Feel free to type in the chat or open up your mic. While you're thinking of a question, we can play with another API. I think the Kanye West one is in here. Oops. Kanye Rest. Yeah, it's a play on words.
Hey, everyone.
Hey. So this is the endpoint for the Kanye Rest API. And if we go into Postman, I'll make a new collection called Kanye, maybe just Yay. And I'll add a new request. We'll make a get request to, I guess, get a Kanye West quote. Paste it in here, save and send. And now every time we send, it's going to send us a new quote. Here we have, one day I'm going to marry a porn star. It's not an appropriate one for this event. But every time we hit send, we're getting back another random Kanye West quote. Perhaps you want to use this in your application tomorrow. Who knows? All right. So I see a question in the chat from A. How do we figure out permissions? I have trouble with adding keys and tokens for logins. Varun, feel free to type your question while I answer this. A, that's a great question. So again, every API is going to be different. Some APIs use what's called an API key in order to prove that you're authorized to make that request. Usually those types of APIs have a developer portal where you will sign up to get an API key. This is really common for weather APIs, for example. By registering your email, you can get a key that you can send in the header of your request. And again, Postman makes that super easy to add. There's the authorization tab. Instead, you click API key here, and you just give the name of the key. The documentation would tell you what that is. Sometimes it's called token, and the value would be whatever key that you got when you registered. So now, every time that you make this request, that key is going to be attached to it and allow you to make it. What's really cool about Postman too is you can do this auth not only at the request level, also at the collection level. You'll see if I click on the Yay collection here, there's also an authorization tab. So I can make auth with API key at the collection level. It will apply to all the requests inside this folder. So I don't have to keep adding it manually to each request. I hope that answers your question. Varun asks, for interacting with the Google server, we can just directly use HTTP request. So when do we need to use HTTP request to an API versus directly to a server? Again, yeah, great question. The first half of our presentation today was talking about network requests in general, like what happens when we call a server and what comes back, how to use Postman to inspect that. You're very correct, that wasn't an API per se, because again, it's designed to be in a web page. An API usually is passing data back and forth that an application can talk to. So again, when would you use an API versus a website? If you're a user and you prefer to, like, as a human, click around github.com, you of course can go do that on the website. But if you're building an application, I don't know why I keep disappearing, sorry. If you're building an application that needs to do stuff with GitHub, it's easier for code or your application to talk via an API than it is via the website, right? You have to click around in here and scroll and all this stuff. With an API, there's no clicking and scrolling. It's you directly modify data. So again, if you're building an application tomorrow, an API might make more sense, than a website. And yeah, not all websites have or products have an API. So you might have to get creative and scrape the HTML of the website in order to get data. All right, so A asks real quick, we have 1 minute left. How do we know when we're using OAuth? You'll definitely know because OAuth is one of the more complicated forms of authorization. Again, you'll never be able to guess what types of auth an API has. You have to read the documentation. If the documentation tells you to use OAuth, you use OAuth. OAuth is a whole topic in itself that we could talk about for a whole hour. But again, on the authorization tab in Postman, again, the drop down different types of auth, you'll see there's OAuth 1 and 2. 2 is the more modern one. Postman is going to hold your hand through OAuth. So that if OAuth has ever been complicated for you, Postman makes it easy. You just put in, you name whatever you want your token to be called, and then you just fill in this information based on the documentation. Postman is going to do the whole OAuth dance when you click this orange button, and it will fetch an access token that you can use to make requests using OAuth. So this is super handy, especially when you're trying to poke around an API and understand what comes back. All right. I hope I've answered all your questions. Thank you all. The slides are here in the Zoom chat, and I'll also send it to the organizers in case you have some Discord channel or something to share it in. And yeah, thank you for your attention. I hope this might help you in your projects tomorrow. Good luck, and feel free to join our Discord and ask any Postman questions if you get stuck. All right, thank you all.
So much.